Lawrence, and thanks for jumping into the early session here with me. My name's Shane Murray from Monte Carlo. As Anna mentioned, I'm the field CTO. My background, just quickly, I started my career in Sydney as a statistician, working on large-scale experiments and experimentation software. That company was actually acquired by Accenture, and I moved to the US, where I consulted with companies to build out experimentation teams and culture and run optimization programs with many Fortune 500 companies. And then I spent 9 years at the New York Times. Actually led the data team there at the Times, increasing the size of that from 12 people when I arrived to when I left. I was leading a group of 150 across the data platform, so where we sort of managed all our engineering and our platform components, the data scientists and the data analysts. And then after 9 years at the time, 6 months ago, I joined Monte Carlo as in this role of field CTO. And so this role kind of has me out speaking to CTOs, CDOs, and other kind of heads of data in organizations, heads of data engineering and data analytics, data science. I've spoken to about 150 data leaders across industries in the last 6 months, really helping to establish observability as a program in their organizations and accelerate their priorities. So who is Monte Carlo? Just quickly, Monte Carlo is a Series D startup, creator of the observability category and writer of this book that there's a little icon there, Data Quality Fundamentals. Monte Carlo has hundreds of customers across media, fintech, healthcare, e-commerce, retail, where we're establishing these observability programs within these customers. So what am I going to talk about today? I've kind of got 3 pieces to this talk. The first is kind of talking through a bit of my experience and the challenge we face with this, what we call data downtime. The second thing I'll go into is just explaining for those unfamiliar, what is data observability? And then the final piece, I'll talk a little bit about what I see scaling trust and reliability in organizations looks like moving into the future. This diagram is essentially, similar to the sort of platform I ran at the Times. It's kind of a conceptual view of a data platform. And, anyone here who's working in kind of data platform engineering may recognize a lot of the components here, essentially starting at the base layer, this green layer with a shared foundation for data management, your warehouse, your data lake, any ETL tooling and transformation orchestration tooling. Moving up, you tend to have the core data for the organization, which can sit both centrally or in a decentralized manner across the organization. My experience at the Times, we had a lot of the core data assets managed centrally, but then we're enabling teams or domains outside of the data platform to build their own data products and manage their own data. The orange layer on top of this is essentially a set of user applications for, analysts or product managers or operations teams to access data and put it to use. So you typically have your business intelligence layer here, maybe an experimentation platform, a CDP, or other ways to sort of put data to use in a kind of user-friendly way. And then on the top, I actually had kind of re-centralized machine learning teams into the data platform, in part to build out these common capabilities, and practices, standards, and technology to enable machine learning teams. And So this is kind of an applied machine learning layer of things like recommendations, targeting algorithms, lookalikes that may be put to use for particular business problems. Across that, you tend to have this kind of governance or standards layer where you might have tools like a catalog, access management, and observability. So the reason I start with this is I think what we've seen over the last few years, especially as machine learning has become more prevalent, as consumer-facing data products have become more prevalent, the data platform itself has become a direct driver of business value, moving effectively from what was a cost center into this role of a driver of revenue at many companies. And so what I found as a data leader is you're not just playing an enablement role, but you're also on the hook for driving real business results. I think the other side to this is the enablement role. Not only are you driving business results through the data platform, but you have many data producing teams who are emitting various forms of data that are making their way into the platform. So, at the times we had when I was there, around 60 digital product teams that were emitting various forms of data, both event data and kind of batch processes. And then we had on the consumer side some 6 different domain-aligned analytics teams, or about 70 analysts that were working in the business to build out reporting and experiments and enable the product and marketing and other teams that they were working with. So it's this enablement role, but I think it's also then imperative that the data platform can support new products, new teams, new opportunities. So if your company were to make an acquisition, for example, you're able to onboard that acquisition, that company to the data platform and benefit from all the shared capabilities you've built. Critical for a data platform leader is to really balance this kind of need to deliver near-term value to satisfy user adoption and satisfaction across the platform, and to build out future value or extensibility of the platform. The kind of existential problem that the data teams and leaders face across these data platform initiatives, I've found is data downtime. I think we've always known this to be the problem, but it's often something we've kind of not so much hidden, but protected from the users of data across the organization. A lot of analysts or engineers spend a lot of time working to ensure data is up to a certain standard before they allow it to be put in a report. And that's been a very human-oriented, diligent process. But just to the definition of data downtime, we talk about this as periods of time where your data is impartial, erroneous, missing, or otherwise inaccurate. And so why is that a problem for data teams? It's a problem because if we come back to this relationship between the platform, the data producers, and the data consumers, what you find is that the data producers have a challenge in understanding both how their data is used downstream and what are all the potential both users and reports that could be affected by, say, a schema change that they might make. And I would say it's not really the fault of data producers. I think they're an easy source of blame, but they've tended to lack visibility over the ways people downstream are putting data to use. And so often we feel like data is just this exhaust from the upstream products. In the middle, you have the data engineer or the data platform engineer who, as it says here, can't predict all the ways that the data will break. Often they sit in the middle, sometimes without the direct knowledge of the source systems, and without the knowledge of the downstream use cases, yet they're kind of charged with maintaining the quality and the reliability of the pipelines in the platform. And then finally, downstream, you have the data consumers who may not know the provenance or the potential hazards within the data, and may not even know who to ask about particular data sets that they're putting to use, but are really charged with driving insights and decisions across the business, and need those to be high quality decisions. I've got a couple more slides on data downtime, but what I've seen is that this problem just expands over time and probably exponentially as the size, the complexity, and the rate of change of your data in your organization grows. So, you know, I've overseen some data products such as financial reporting data, where you actually take upstream e-commerce data, you kind of massage that into a subscriber view of, or a view of the customer, and then you produce financial metrics which are used both in financial reporting, but may also be used in day-to-day analytics to support the business. And so there you have this need to be both accurate, kind of to the penny of the general ledger, but also to have the data available at, say, 6 a.m. every day. And then on top of that, you know, most organizations, digital organizations, will have a kind of a backbone of core product data or event tracking data. I mentioned at the times we had 60 odd product teams. And what you find is this data is always evolving. It's critical to all of your metric development across analytics and data science teams. And it may not need to be as accurate as the financial data, but it needs to be directionally accurate. It needs to be available for often real-time or near real-time use cases. And it needs to be applied consistently across the business. And so these problems, as I said, kind of expand over time. And as we've seen more companies start to adopt kind of data mesh-like approaches and start to federate data product ownership, it becomes an exponentially larger problem that can't really be solved through traditional techniques. I'll end my downtime part of the talk on the consequences of data downtime, which, as I say here, they can range from really trivial to existential. So what I find is it's depending on the time to detect and who actually discovers the issue. You know, if your data engineers discover the issue early, the only consequence might be lost engineering time. I say that as the only consequence, yet it is often quite a costly one for engineering teams. This stat here, which we've collected across Monte Carlo research, that 30 to 50% of data engineering time is spent on these fire drills. But then you can actually, you know, get into worse problems if it's uncovered later, or if it's uncovered by a stakeholder. It could be a loss of trust. If it's uncovered by customers, it could be a loss of revenue to the business. And kind of at the end point here, if it's uncovered by the public or Wall Street, it could be a real loss of reputation for your company. And so another stat here from Monte Carlo, we've seen for data teams about 70 high severity incidents per year for every 1,000 tables. So that's a benchmark we've kind of collected at Monte Carlo. And, you know, if you compare that to the kind of parallels in system or application engineering, we see a lot more high severity incidents in data than we do in these applications. And then the final step down the bottom, which is from a Gartner study, companies quote sort of 15 million in average annual financial costs to data quality. So I'm going to sort of branch into the solutions here to data downtime. And where teams tend to start, which is with manual tests. When I was at the Times, we used an open source tool called Great Expectations. We also built an internal tool at the Times that was used by many analysts to sort of understand anomalies and deviations from expectation. And this is where most teams should and do start, which is defining manual checks on their data. Things like checking the rate of nulls on columns, maybe checking that and validating transaction price and other predictable anomalies. The challenge is that these often fall short. You can only really test what you predict or what you know about the data. You can't necessarily see downstream or upstream in the same way. And these queries can actually become quite costly even to run. And finally, it's just very hard to scale this approach. Manual testing can be all-consuming if that's your one approach to solving data problems. The other thing we see is that about 90% of data incidents are caught by downstream data consumers, which could be data analysts, but they also could be business users or executives. I think everyone's got examples of business users kind of uncovering an issue in the data and pinging them on Slack or notifying them that the data looks wrong. And just an example from my time at the New York Times, we had a data product that was used by 2,000 journalists for really up-to-the-minute info on their stories. And if anything looked off, you'd get any one of those journalists maybe pinging you on Slack to let you know. So over time, that trust can really degrade and affect the trust of the data team. Okay, so what is observability? We find that this data downtime looks pretty similar across companies. You can probably expect this. And so the way we look at data downtime is really through these 5 pillars of data observability. The first one is freshness, so ensuring your data comes in when you expect it. As you can expect, that differs depending on the data. You might have data that comes in every 10 minutes. You might have data that arrives once a day. And so you need to learn the cadence of that data and respond to that cadence. Second is the volume. Are you getting the right amount of data? Is nothing missing or duplicated? Quality metrics being the third. So this could be distribution or quality of the data, including the nulls, the duplicates. Are you seeing cents instead of dollars or other form of broken records that you could identify systematically? Schema change ensures you're aware of field additions, modifications, and omissions. And then bringing it all together, I'd say, is this idea of data lineage that helps you better understand the downstream impact of broken tables and the upstream root causes. And so you can actually then overlay data incidents onto the tables and fields where they occur. If it hasn't become clear yet, what is data observability? It's an organization's ability to fully understand the health of the data in their system. And if anyone's familiar with DevOps and tools like application observability, so tools like Datadog, it uses the same sets of practices and tools like automated monitoring, alerting, and triaging to identify and evaluate data quality issues. This leads to more reliable data, healthier pipelines, more productive teams. And so I've broken it down into these 3 categories that are kind of critical and sit on top of the observability pillars. First, you have detection. So you have ML powered detection. As I mentioned, things like freshness depend on the type of data. And so you actually want to observe how often data is being updated so that you can test anomalies against that. On top of that, you might have rule-based detection that's part of any kind of deep detection strategy. And these are often more business-specific rules like accuracy that you can define maybe against some comparison data set. And then a critical component of the detection strategy is kind of managing this signal to noise. You don't want to have a ton of alerts flow out to your users or your engineers if they're irrelevant. And so targeting alerts to the impacted owners and the downstream users is a critical component to a good detection strategy. Going into this middle column here, you have resolution. So beyond detection and alerting, data observability must also deliver the workflows and tools to quickly resolve data incidents altogether. You know, one of the components there would be automating field level lineage for downstream impact analysis and upstream root cause analysis. A thing we call either the impact radius or the blast radius to see how many users and reports are affected. And then thirdly, integrations with other tools in the data management stack like dbt and Airflow, so that you have diagnostic info to resolve issues. Thirdly, you have the kind of prevention part. So this is where you actually want to produce insights and reports based on metadata from your data warehouse on what tables maybe are frequently used downstream and how you can maintain a clean environment that's focused on where people are using the data. You can also, we see a lot of teams proactively start to use schema notifications related to sort of new product launches so that they can ensure they're not introducing problems into the system. And then circuit breakers are another means to stop pipelines that don't meet a certain quality threshold. So I think I've roughly covered this, but often testing is this great way to get started. Sanity checks, alerting when you don't pass certain thresholds of quality, but it's really hard with pure testing and sanity checks to anticipate all scenarios. Monitoring is much more automation first, so you can alert when certain predefined metrics are off. But the team tends to still need to manually choose, you know, what tables they want to cover and what metrics they want to be looking at from a monitoring perspective. Observability is the way to really scale this practice and proactively monitor all your tables so that you can uncover breakages anywhere they occur without having to predefine tests. And then collecting, as I said, logs, metadata, and lineage so that the team can quickly get all the context they need to triage and resolve issues. Okay, I'll spend the last couple of minutes here on, you know, just some thoughts about scaling trust and reliability and the future of where this is going. The reason I sort of introduce trust and reliability together here is you know, quality has been, data quality testing has really been around for, you know, many years. But quality itself refers to the state of the data. Is it fit for use? And so, you know, when we think about reliability actually considers the quality changes over time in a variety of real world conditions. So this is the difference I see between quality and reliability. Just a parallel example, if you consider an airline, you know, you might measure the quality of an airline based on the timeliness of the flights, the safety, you know, has it had any major incidents, and maybe the food service, you know, how the standards of the food you're getting on that airline. But in order for an airline to really build trust and reliability, It needs to maintain those levels of quality over time across various routes, across various weather conditions, across peak periods and troughs. So, to build trust, you really need to weather various conditions. And the same is true for your data environment. To be reliable, you must assess whether your data products and your warehouse can really maintain these service levels. And for data, that could be freshness, completeness, consistency. Can you maintain those over time across maybe holiday spikes in your traffic and various product launches? Data reliability then is important. I've talked about some of these things you're doing, so automatically kind of capturing metrics, traces and logs to observe and ask questions of the system, but also this idea of establishing service levels. And so this could be the percentage uptime you're looking at, and also the time to resolve. And commonly, we talk about this in terms of SLAs, service level agreements, or SLOs, service level objectives. And so that's where I'm talking to a lot of customers these days about how to implement that either across the most critical data to their organization or across their entire, data workflows, having some level of SLOs across every data product in the organization. That kind of brings me to how do data teams really get to that level of maturity through observability and begin to measure things like uptime and report that out to the business. What I typically find is from a maturity standpoint, you tend to start with building operational muscle. So this is adopting observability practices amongst data engineers, putting out-of-the-box coverage across tables, creating alert routing strategy. You might establish on-call rotations and weekly incident reviews. And the benefits of those practices show in starting to get early detection and communication of incidents. So often, a KPI there might be the shift from a reactive response to incidents to proactive response. We also see that customers tend to have be faster to triage and resolve incidents during that time. So measuring things like time to detect and time to resolve. And commonly you'll see teams reduce the time from, say, an average of 3 days is something we've measured down to less than 1 day. The second kind of level of maturity, I'd say, is establishing service levels. Often here, you might even extend adoption out to analysts and data scientists, start to put in place more custom data quality checks to tackle both the breadth and depth of potential incidents that can occur on data. And then, establishing SLOs on critical data products so that you can report on the uptime of this data to your consumers and manage against that uptime. And so I mentioned earlier sort of that rate of 70 to 1,000 incidents per table. You can start to sort of measure something approaching, the 2 nines or 3 nines or 4 nines of application reliability that engineers on the software side will talk about. Once teams have put in place those standards around service levels, this tends to be aligned with sort of data mesh strategies, but you might look to federate these standards out to either data producers or out to domain teams and make observability part of a kind of self-service data platform for the organization. This would mean sort of federating that SLO definition, reporting, creating visibility into the health of a data product at its point of use. So as an analyst or data scientist or consumer goes to use a data product, they should know whether it's breached that SLO or whether it's safe to use. And then starting to kind of govern across the domains and increase the kind of velocity and output of the data platform. Across all of these maturity levels, you're looking at outcomes like saved engineering time, fewer incidents, increased uptime, and established trust across stakeholders. I'll give I think I'm at time here, but I'll give a really quick plug to the O'Reilly book released by our founders, Bar Moses and Leogovich, Data Quality Fundamentals. And you can pick up an early release copy via that link. And then thank you. If anyone wants to contact me about anything I've talked about today or to discuss data generally, you can reach me at this email address.